Hi guys, welcome to this session. This is Faizan from Great Learning. Before we start, can you guys quickly put a yes message in the chat section if you guys can hear me properly or not, or if there is any problem, you can tell me. If there is an echo or anything, just write a yes in the chat section. Quickly guys, I'm waiting. In the meantime, Great Learning has come up with an initiative, that Great Learning Academy. In that we have 100 plus courses available for free for a limited amount of time. You guys can also check that. Okay, cool. You guys can hear me? Okay, now let's get started. Sorry. So today's session is all about competitive programming for beginners. Okay. Now before we start, are there any prerequisites for this session? No, there are not. Okay. So the only thing that you need to know is that you must be able to understand the English language properly. As if, what do you mean by this thing? Because there are many competitive programming, there are many competitions in which there is a huge paragraph of questions, right? There is a huge, maybe 10-20 lines of a little bit of noise, but okay, cool, Rahul. So, there are many questions which are maybe approximately of 20 to 30 lines, right? All written in English language. So, you need to understand the language properly, the English language. I know some of you will not comfortable maybe in English, but that's okay. If you want to learn English, maybe go watch a movie, okay? Go watch, Harry Potter series, right? Go watch Lord of Rings, so that you can get an idea of what things and try to stop it. Use the subtitles, okay? So you can do that thing, okay? So you need to understand the language because there are 100, maybe 20 lines of English sentences. You need to understand. The gist is very small of all those lines, but you need to understand that English language very properly. Okay, cool. So now another thing. So today what we are going to study in this session is how to approach a problem. Okay, how we reduce our time complexity. And another question that right now in this session. In this session we are going to we are going to cover some algorithms, okay, and also I'm going to use Java as my language, okay, Java as my programming language. Right now some of you might be in second year BTech, okay, BTech second year or third year or fourth year, right? So for second year students it's easy to switch language, right? But for the fourth year students who are who are about to get started, right, who are about to give some interviews, for them to learn a different language is very difficult, right? So you need to focus on the coding part rather than going for a new language. You should focus on the coding thing, okay? So if right now I'm using Java, if the fourth year students or third year students are using any other language, they can easily code in that, okay? There's no issue, okay? And for the second year students, maybe you can switch to C++ because C++ is the most widely used programming language, when you talk about competitions, okay? So without wasting any further time, let's get started with the session. So this is the first question. I want you guys to analyze this question, okay? Find the element that is present once in an array where every other element is present twice. So for example, yes, Khushbu, you can learn. You are a BSc student. You can also learn. So this is for beginners, okay? So everything for if someone has been coding for quite a while, so he can also attend this session, and someone who has just started, he can also, okay? Cool. So this is the question, right? Find the element that is present once in an array where every other element is present. I'm new to software engineering. No issues, Sai. So let's see the question and now let's try to analyze this. What are the things that we have to do? Okay, the input is 1, 3, 5, 6, 6 and 3, 1. So every element is repeated twice. 1 is repeated twice, okay? Yes, Deep, Jyoti, you can also attend. Everyone can attend this. It's easy to switch from Python to Java. Yes, it depends, okay? Yes, it is easy. So try to analyze this question. Yes, JavaScript can be also used. Any language can be used, as I told you earlier. So there is no issue if you are comfortable with that language, okay? Yes, for fourth year student, yes, you can. 11th class students we use Python? Yes, we can. There is no issue, okay? So every element is present twice. Okay, 1 is present twice, 3 is present twice, 6 is present twice. We have to find this 5 element, the number 5, which is only present once. Similarly is the other example. So if you can analyze this, you can easily solve this problem using 2 for loops, right? One will iterate over the first, for 1 will be compared with all the elements to check if there is another 1. 3 will be compared with all the rest of the elements, then then we will see if it is present or not. So the first approach is using nested loops. The time complexity of this approach is n square. Why it's n square? You guys must have a little bit idea of time complexity, right? I will cover a lot of things, but you need to understand that whenever I am talking about array, okay, there is one thing you need to understand, that the array length, that is n square, the time complexity, the n represents the length of the array. Okay, so the length of the array wherein we will traverse, every element will be compared with n elements. So for every n there will be n comparisons, right? So the time complexity of this thing is n square. But now this is the naive approach, right? This is the 2 loops, Raghavendra, right? Yes, 2 loops, right? So this is the most naive approach, right? So if you solve this thing in your, face-to-face interviews, when you face this kind of a problem, right? So you won't be selected, right? This is the most naive approach. We need to understand that some things, right now we are in such a phase that everyone wants things that are efficient, time efficient. We need to save a lot of time, right? Now, if we have, for example, right now we were having 6 elements. For example, if we had maybe 10 million elements. So 10 million elements into 10 million elements. So there is a lot of time required for this thing. Maybe right now we have such systems that support these things, but it's not an efficient thing to use the for loop. So we will compare, right? We won't be checking, 1 will be compared with 1. It might be the case that you might think that, okay, the 1 has been compared with, I want you guys to have a page or a copy in front of you so that you can just follow along, and a pen so that you can drive on this, okay? So now 1 will be compared with itself. So that's why I said I not equal to j, okay? This thing that if I is not equal to j and array of I is equal to array of j, right? So now I will check. Now the comparison will happen, right? Yes, I will come to that. This is the most naive approach. We will just, you see how we shift from n square to maybe n or something, right? Just wait, give it a time, okay? Psi. Okay, so this is the most naive approach one can think of, right? So can we do better? Yes, we can. How? Now let's try to think how we can do better. Okay, let's see this one. Now I use sorting. So you see how the complexity shifted from n into log n, right? So earlier it was n into n. Now it's n into log n. Okay. Before I get further into this thing, I want to show you something. This is the GitHub. This is the time complexity sheet that someone made on the GitHub, and he uploaded this thing. You see this chart. So the best complexity is of algorithms which are having time complexity of log n or a constant time, right? Big O of 1. The last line, which is represented by green, that is written excellent, right? So why j is equal to 0? Because we are comparing each elements, right? We are comparing each element from if 1 is compared with all the elements, so it will be, that's why we will start from all the elements, right? Maybe sometimes if you try to dry run this, Raghavendra. So if you see that 1 will be compared with all the elements, right? Now if we talk about the third element, which is 3, maybe it is present at the second position. So you need to start from the beginning, okay? Okay, Raghavendra, got the point? Sort n log n compared to adjacent numbers. Exactly. That's what we did, right, Rajat? So now you see this chart. So the best time complexity is of log n and constant time, right? Now after that there is n. After that there is n log n. Then there is n square. Then 2 raised power n, and then n factorial. This is the time complexity chart, right? So the worst time complexity in this chart is horrible. That is written horrible. So these are horrible things, right? Horrible time complexities. N factorial, 2 raised power n, and n square. So what we did earlier was n square, right? the first approach. The second approach is n log n, which is also bad, right? The orange section, if you can see above, it's written bad, right? Clear? Are you getting this thing? So the time complexity, the orange part is written bad. Then there is fair, right? And then log n and these things are excellent. Okay. Now let's go back to our approach, the sorting approach, right? So now what we did, we sorted these elements, right? For when we use in Java, when we use arrays.sort, basically it sorts using quick sort. Now if you're creating one of your own objects, right? You're trying to sort elements. For example, you created an object student, right? And then you're trying to sort the name by name, right? By name is not something primitive, right? So at that time it uses merge sort. Right now, that let's not go into that thing, but because it's completely language dependent. So right now, if I talk about arrays.sort, okay, yeah. So now right now, if we talk about arrays.sort, right? So this will sort the array, right? Now elements will be in sorted order. So obviously one will be if you sort these elements, so what will be the output, right, of the array? 1 1 2 2 3 3 and 4. 4 was the 4. Let's suppose 4 is not repeated, or let's suppose 3 is not repeated. So 1 1 2 2 3 and then 4 4. So if I compare first element with the I plus 1 element, right, it will be always same, right? So if maybe in case of 3, it won't be equal to 3, right? Therein we have 4. So we can easily deduce that this element is not repeated. Cool. So arrays.sort will have a time complexity of n log n, because we are using quick sort, right? So for quick sort, the time complexity is n log n. So that's why. And for the for loop, we iterate all the elements once. So plus n. So obviously, when we talk about time complexities, we always take the bigger ones, because as soon as our n increases, right? If we talk about 10 million elements, right? So that can be negotiated. So we always talk about the bigger one. If there would have been something that you did, for example, there would have been, sir, I can't understand. Okay, just give it a time. Give it a time, Radha. Okay, just give it a time. Easy. It's easy to understand, right? So listen to me carefully. You understood the first approach, right? Just quickly write a yes or no, Radha. Quickly, Radha. I'm waiting for your answer. So you understood the first approach, right? We use 2 for loops and then we compare the elements. That's it. If you can hear me. Okay. Okay, let's get started with the next approach. Okay. So next approach, I used quick sort, right? I sorted all the elements. Then what I did, I compared the first element with the, cool Radha. So then I compared the first element with the next element. Let me just debug it for you, okay? So Radha is saying that she can't understand. So let's see. So earlier what it was unsorted. Now we have 1 1 2 2 and then 3, then 4 4. Okay, this is the array elements we have. Now what we are doing? We are comparing this element, this that I have highlighted, right, with 1. So obviously with the position, what are the indexes? Right, let's write in the indexes as well. 0. Okay, Surya, tell me your doubt. We have 2, then we have 3, then we have 4, then we have 5. These are the indexes, right? So now we starting iterating from 0th position, right? Now the 0th position is compared with I plus 1 position, that is 1. That's what we did. If you can see here, I is compared with what? I plus 1. If they are not equal, then we were able to find that this is the element, right? This is the element that is not repeated, okay? Now let's go back to this thing, okay? Now I is compared with I plus 1, cool? Now, then are we going to iterate to 1 as well? No, right? Because this has been already checked. So that's why my loop here is, I am doing I plus 2 here, right? I plus 2. So I am doing two pointers, the ith index. So it will be at 2, right? So now 2 will be compared with the index. Now index 2 will be compared with index 3, right? Hey, what's going on? Gabriel, we are trying to understand the second algorithm, right? The second approach of the question. Have you listened to the question? Sorry, have you listened to the question? Just write me a yes or no so that I can repeat the question for you. So this element will be compared with this, then 3 will be compared with 4. So we found that 3 is not equal to what? The index at fourth index is not equal to fifth index. Okay. We will come back to that. So basically what I am trying to do, maybe you might have heard this question, right? But what we are trying to do, we are trying to deduce, and maybe you won't be that won't be a case when every time you will get such a question that you have already listened, right, or you have heard of. Sometimes this thing happens when you are not able to when you are not heard about this question, and the first time the question comes, how we deduce from burst complexity to efficient time complexity. So right now what we did in the first approach, we were using n square. In the second approach, we are reducing it, right? Now we are using n log n. So this is the thing, right? We use sort and then we compare the elements. Can we do better? Can we do better is the question, right? Yes, we can. Now, what I was smart enough to understand that, okay. Now what I tried to be smart. I tried to outsmart my interviewer. What? Okay, I will use some space complexity, right? I will use some extra space and then try to solve this question. So now you see, I moved from n log n to n time complexity, because in this case I will be iterating every element only once. Okay. Now let's try to see iteration. Sir, in the iteration I plus 1, it should be 2. Sir, how are you doing? How you are doing that? Okay. In this question, okay, you I plus 2. Okay, this is the thing when you try to iterate 2 elements at a time. So usually what we have, I plus plus, right? We have at that time don't know anything about hashing cell. We will cover it. We will have a little bit of idea. Maybe then you can do your research. Okay, cool. So now what we did in this, one was compared already with the next element. So what we did, we just skipped that element. So that's why I plus 2. Okay. Okay. So okay. Also there is one mistake in this. What is the mistake? Can anyone tell me quickly? There is one mistake in this. The looping is right, but there is one missing one thing that is there is a problem in this, the second approach. Yes, the second approach, there is one thing. Can quickly guide anyone can rectify that problem and tell me? Let's suppose we are at the end of the index. So at that time it will throw you an error. What? Array index out of bound, because we are comparing one element ahead, right? So you need to just minimize that thing, right? So what you have to write, array dot length minus 1. Okay, cool. So now let's go to the hashing part. So what we did now, what we are trying to do now, we will use a hash map. Basically, hash map is the most commonly used data structure when we talk about competitive programming. Okay. Now, Raghavendra, break is not an issue. After compare, you not print use break. Okay. Yeah, you can do. It is quietly totally dependent on what your question is. What's the requirement of your question? Right now, I don't have any question, so that's why I used break and printed the element. I didn't check all the elements. So there is always a case. There will always be one such element which is not repeated. Okay. Rest, there will be no case. Okay. Now it is completely question dependent. For example, right now what I am using, that there will always be one element which is not repeated. Okay. Cool, guys. Okay. Okay. Now let's try to think about this approach, right? The space wherein we use space. Okay. Now hash map works in such a way that if there will be always a key and a value. Okay. So now what I thought when I was solving this problem. So during my interview, what I thought, so if I easily used the key as an integer number, the number which are 1, 2, 3, 4, 5, the elements which were present, and after that I will write its frequency, right? Let me show you what I thought of. So I am giving an intuition how to reduce your time complexity. Basically, you can easily solve this question. I know most of you guys might have known, but it's not usually the thing that you might face a question which you have already heard of. Okay. So now what I'm using a hash map, in that the key will be 1, okay, and the value associated with this will be, for example, 1, right? I'm iterating through this. I see that 1 is not present. Okay. Now the next time it came again, 1 came. Okay. Then the frequency will be 2. and then for 2 the frequency will be 2. Okay, this is a hash map. Okay, for 3 the frequency will be 1, and for 4 the frequency will be 2. Okay, now you see this is the map that I created. Okay, this will be the map that is going to be created. Okay, now what we are trying to do, we will just iterate through this map. Okay, what we will do, we will check all the elements which are having the value 2, those will be skipped. Yes, you can do that, Raghavendra. Yes, you can do that as well. Okay, right now what I am doing, there are many approaches that one can use on any problem. Okay, just you have to be sure that it is efficient from the previous one. Okay, now this is the map that I created. I inserted all my elements, and the value that is associated with it will be the frequency. Okay, so now what I will check, I will pick up the key and then check. If its frequency is 2, skip it. Then I pick 2. If its frequency is 2, skip it. Now I pick 3. If its frequency is 1, then I will print that element, and that will be our missing element, or the element which is not repeated. Okay, so that's what I did. I created a map, then I iterated through the array, right? I check if it's already present in the map, right? When I talk about the first iteration, right, 1 is not present, nothing is present in the map, so that's why I check if map.contains key. If this key, 1 is already present in the map, then what I did, I picked its value and incremented by 1. So earlier it would have been nothing, there would have been nothing in the map, right? I have 1 year left, I moved to a competitive, I want to build a career in ML and data science. Okay, no worries, but still, if you want to build a career in something like AI, ML or data science, right? So there is always one round which will be associated with what? With your coding skills, right? There also you need coding, right? So it is beneficial for everyone. Not if you're talking about AI, ML or data science, everywhere when you go into the interview, there is always one round associated with every company that is regarding your coding skills. Okay, you will be asked such questions, so you need to understand this thing. How would we try to build an algorithm which is efficient? Okay, so Raghavendra, I'm repeating this thing. Okay, just give me some time. Okay, yeah. So we created a hash map. So earlier, what was this thing? The scene was this, that there was nothing in the map, right? Now I iterated through the array. Yes, Manish, there can be many approaches. Right now I'm using the basic approach, right? I can't understand the third approach. Okay, Tejas. So what I did, I used the hash map. So earlier, is there anything in the map? If you can see here, nothing is in the map. Okay, now I iterated through the array. I got 1. I checked if this 1 is already present in the hash map. No, it is not. So what I did, I inserted 1 and 1, the frequency of that. Okay, then 2 came. Okay, I check if this 2 is already present in the map, right? No, it is not. Okay, so I inserted 2, and then the frequency of that is 1. Okay, this is what the thing that I did. Let's watch this thing right here. Let me minimize this thing. Okay, you see, if it's not present in the map, I wrote map put array of I and the 1. Right? That's what I'm doing, right? Let me go back to this thing. Okay, right? So now 1 came again. Okay, 1 came again in the array. The third index was 1 again. Okay, so what I did, I checked if it is already present in the map. Yes, it is. So what I did, I just got fetched its value, right, which is 1, and then incremented this 1. Okay, then this incremented this 1 to 2. Similarly for all the elements. Okay, so that's what I'm doing here, right? Map.put array of element I, again I'm putting this and I'm getting the previous value and incrementing it by 1. So this is the problem, Manish, that every element will be repeated twice. Okay, except the one element will not be repeated. Okay, we need to find that element. Okay, and it is always the case that one element will not be repeated. Okay, so now what we did, we inserted every element in the map. Then what I did, so our map will be something like this. So there will be 2, okay, then there will be 3, which is having frequency 1, right? And then again there will be 4, which is having frequency 2. Now what I did, Now I will be fetching, okay. Now I will be fetching all the key set, that is 1, 2, 3, 4, okay. All these keys will be fetched, okay. Now I will check. If the value associated with this key is 2, then skip it, okay. If it is true, then skip it again. Then 2, then 3 came. If it's 1, I will print it and break out of the map. That's what I did. I fetched all the key set, then I compared. If map.getX, that is get the value on this of this key, that is 1, I got 2, right? So then, yes Manish, we are coming to that. Yes Manish, we are going to use that. You are absolutely right. So this is the thing. Now the interview told me that I don't want you to use any extra space. The space complexity should be constant, okay. So now I thought about what are the things that I know. Maybe he gave me a hint that please use XOR operation, okay. So finally, if you are able to solve this approach with this approach, you will be, there is 50-50 chance that you might get selected if this question comes, rather, or if you are able to reduce your algorithm from what, n squared to n, okay, n, this with space complexity, there is a chance that you might get selected. But if you are not able to do this the approach, he might give you hints, okay. So now let's talk about the fourth approach. It is the most optimal approach, okay. Now you all have heard about XOR operation, right? XOR. So XOR is the let me show you the bitwise XOR operator. So if the element is same, right? The element is same, right? 8 XOR 8 will always give you 0 as your output, okay. So this is the output that you will get, okay. And if you XOR 8 with 0, then it will again give you always give you 8. So if you can check the input X, if the bit is 0 and the other bit is also 0, then it will give you 0, else it will give you 1 if one is 0 and one is 1. So you got the point, right? So this is the XOR operation which will always give you a result. If you try to XOR same elements, right, that will give you 0. So that's the thing what I used. The simplest approach is that loop around all the elements, okay. Now and store it in a result and keep XORing each element with itself, okay. So if you can check, right, then you will get the result. How you get the result? This is what we used, right? If you can see, 1 is XORed with 1. What will be the result? 0. 3 will be XORed with 3. What will be the result? 0. 6 will be XORed with 6, right? What will be the output? 0. So then 0 will be XORed with what? 5. What we will get? We will get 5, right? So this is the simplest approach one can think of, okay? And the time complexity of this is n, right? We are only iterating each element once, right? And the space complexity, we are not using any extra space, is constant, okay? Just quickly write, guys, that you understood this problem and all the approaches, right? So basically what my main objective was to keep this example, use this example, because it's not, you need to think, right? You need to think, guys, right? I won't be able to solve each and every problem for you. Competitive programming is all about practice, knowing the concept and how you deduce this. Now this thing that I used here, you can easily use this thing everywhere, okay? You can easily use this thing everywhere on every problem, right? Think about the naive approach, then try to reduce the problems, okay? Then try to reduce the time complexity, okay? And space complexity. Maybe use extra space. So after, if the interview is not happy with that, maybe you can then skip the space complexity part, and then he will also give you maybe some, but third has some confusion. Maybe because that Prashant, that you might not be knowing what the hash map thing. You just go after the lecture is over, just go once again, understand the concept of hash map, because that is something related to Java and something related to maybe if you're using some other language. So go into that hash map and then you will be able to. Okay, cool. So now what we did, we just reduced our time complexity and increased the space complexity, okay? This is the thing, right? You understood all the algorithms were understood, right? This is you can easily, maybe you can easily implement this in all the problems, okay? Now, what if these elements were already sorted? The same problem. I'm trying to build something here, okay? Something substantial. I'm using different types of things, right? The time complexities and the algorithms, okay? Now, what if the array, the elements which were already present in the map, right, which were already present. Okay, can you explain a little about space complexity? Yes, sure. So the space complexity is whenever you're trying to store something, maybe if you're trying to store n elements, right, I am storing all the elements, right? So the n represents here the number of elements. So I am utilizing the same amount, same number of elements in some other thing. Maybe if I store them in an array, right, all these elements, again the space complexity will be n because I am storing all of these elements. Maybe sometime if there are eight elements in an array and I only stored 3, at that time maybe you can say that the space complexity is log n, maybe. So okay, it is always dependent on your question. So space complexity is something that when you use extra memory. Okay, so right now I'm using n number of elements to store these elements, so that's why the space complexity is n. Okay, you will get these things. Don't confuse yourself with all those things. So right now what we are trying to focus here, how we reduce our time complexity. You will get these things. This is not something you will get in a single lecture. Okay, give it some time. Yeah, give it some time. The amount of, yeah, exactly, yeah. So now this is thing. What if these array elements were already sorted? So we used the earlier approach, right? We used this thing, right? When we sorted, then we looped around, right? When we checked what the first element with the second element, right, guys? We checked these elements. Okay, so 1 will be compared with 1, 2 will be compared with 2, then 3 will be compared with 4. That's how we found out that this element is not repeated, right? If the array elements are sorted, right? If you can see the example 1 1 3 3 5 5 and 6 6, so the output should be 5. Using loops we can do it, but can we do better is the question. Whenever I say the elements are sorted, there are two things that quickly should pop up in your mind. What are the two approaches that you can use? So obviously it is sorted, then you can easily use a 2-pointer or an binary search. Okay, right? So which sorting is the best? It is completely dependent on the approach that you're using. This is something vague, right? Something vague. What do you mean by that thing? So if sometimes maybe I will tell you one little example. So there are 10 million elements and you want to sort. Are you going to use some extra space? No. So the merge sort is gone. And are you going to use quick sort? No, that is also gone. Maybe you can use heap sort because that the space complexity of that is constant, right? It doesn't use any space complexity, right? The heap sort, right? So it's completely dependent on there is no such thing that this algorithm is best or not. It's completely dependent upon your question. Okay, cool. Now, can we do better? Can we do better this thing? Can we use something? So the 2-pointer thing. What does the 2-pointer mean? This is the approach that we are going to use in this problem, right? So now it's having the same complexity. Maybe it's having same complexity, right? The n complexity. But the objective here is maybe when you get elements which are sorted, the 2-pointer mechanism can be applied. Okay. Now if you can see what I did, the space complexity, and let me show you something here. Okay. The how 2-pointer works. Okay. So basically you will get elements in such a manner, right? 2 2 and 3 and 4 4. Okay. Now what we are going to do, we are going to use 2 pointers. One will be pointing to this 1 and other will be pointing to this 4. Okay. Cool, guys. So now what we will do, we will check if 1 and the other element is same. Okay. So one will go from front and one will go from the rear end. Okay, from the last end. Okay, the last element. So I will check if I and I plus 1 are same, and if j and this will be pointing to some index, right? This is the 1 2 3 4 0 1 2 3 4 5 6. So 6 will be compared with 5. So I will check if j and j minus 1 are same. Okay, that's what I'm going to use. See. So obviously I will traverse only that much amount of time, that many iterations I will do unless and until the left pointer is less than the right pointer. If that is not the case, then I have already checked them, right? You just need to understand this thing. Okay, I'm trying to build something based on the same problem. Okay, I'm trying to visualize you the things that can be done. Okay, this goes for each and every problem, right? The problems are enormous. There are huge number of problems, many number of problems, right? But the point here is I'm trying to use same approach so that you can just map around it. Okay, you can just visualize these things. Okay, so now what I'm doing, I'm comparing 1 and 1, and that's the thing what I did. If array left pointer is not equal to array left plus 1, okay, so if it's not equal to that thing, right, if it's not equal to 1 is not equal to 1, right, in here, okay, 1, if 1 is not equal to 1, then obviously I will find out that 1 is not being repeated, but that's not the case. And similarly I will check if 4 and the previous one, right, you did do your work, don't disturb us. Okay, cool guys. So 4 and fourth index and fourth index will be checked. Okay, if 4 and its previous element, right, that's what I did. If the right pointer and right pointer minus 1, why minus 1? You got the point, right, Radha? Okay, Radha. And also write comments, write a chat, keep interacting with me guys, so that we are on the same page. Okay, so now 1 will be compared with 1 and 4 will be compared with the previous number, right, previous index, right? So if both of these are okay, right, then what I did, I incremented left pointer by 2 elements, right? That's what we are going to do, right? Manish, if while loop condition already checks its right, and then why is it necessary to check in the if conditions? Because, yeah, good question, right? Alright, Manish, because we are checking this thing, right? The Manish, let me first explain the whole algorithm, then I will come to this thing. Okay, so now what we did, so after we compared 1 and 1 and the last element 4 and 4, okay, then I incremented the left pointer by 2 elements because 1 has been already checked. Okay, then again what I did for 4 and 4, I decremented it by 2 because the other element has been already checked. So now where will be the pointers? The pointers will be the left pointer will be on 2, right, and the right pointer will be on 3. Okay, now Manish was asking why we have been checking this while condition, right, while left pointer is less than right pointer. That is obvious, right, that we have to check because we don't want to do something that has been already done. Okay, now what we are doing here, what if Manish, what if, because the concept that we are using here, we are checking the element after, right, left pointer and the next element to the left pointer. Okay, maybe if that time I have already done that thing. Okay, because I am not in the while condition, I am not checking left pointer plus 1 and left pointer minus 1. That's why I have been checking. I need to check because I am seeing the one pointer ahead, because right here if you can see left pointer plus 1, so this plus 1, this has to be there, is in the array, right, if I have already checked that thing. So you need to check the condition. Okay, that if you might not have been checking this element already, if you might have checked this element already, right, so that's why I am using this left pointer in both the if conditions. Left pointer should be less than, maybe to check if there is an element, right, you don't want to be repeating the number of checks. Okay, so once I did this thing, right, the pointers are here, right, this will be one pointer, left pointer will be on 2 and right pointer will be on 3. You see, right, there we will see the difference. Now the 2 will be checked with the 2, right, left pointer plus 1, right, it will be checked with 2. Okay, he sees that this is not the element which is now this condition, if condition won't be executed, right, because the 2 is already there. I am checking for the not operation, right. So if the case is that this is not already present, then I will only check the elements, right. You got the point, right. Maybe it's confusing a little bit because you are not trying to dry run it. Okay, so 2 will be compared with 2. Okay, now left pointer is less than, right, that has been done. Now this, you see, 3 is been compared with 2 and our left pointer has already exhausted this thing, right. So 3 will be compared with 2. Okay, now you see, right now it is showing that our left pointer is less than, but still we are checking this thing, right. So the 3 will be compared with 2, and once we will do that, we will see that this is not 3. Okay, now we got that point that this 3 will be our element which is missing. Okay, you got this 2 pointer approach. maybe you won't be able to see the huge difference in terms of time complexity, right? Because it's also using the same time complexity, right, the n. But the objective here is, once if you have some time, maybe you will face a problem which is sorted, and you want to do something, the two-pointer approach comes there, and you can use that. Okay, that's the main objective, not the thing that I have reduced the time complexity. No, I haven't. Okay, now can we do better than n? Yes, we can. Whenever we talk about some there is an array in which the elements are not repeated, okay, in which the elements are sorted. At that time, you can easily implement what? Binary search. So let's try to debug. Let's try to see how we can implement binary search. So the main objective here is that if the elements are sorted, you see, if there is no error, you see, can anyone tell me? Most of us know that binary search can be implemented on the elements which are sorted, or on the array which is sorted. Is that always true? Just write yes or no. We can only apply binary search when the elements are sorted or not. That's the case. That's the answer I want. Sir, please explain the second approach here. Okay, the second approach is that I'm using two pointers. One is pointing to the first index and another is pointing to the last index. Okay, so then I'm comparing the first index with the first plus one index. Okay, so one will be compared with one, and the fourth index with the previous one, right? Left pointer minus 1. So 4 will be compared with 4. Okay. Then I am trying to shrink the array. Okay. No. Okay. Football says no. TV Tech football. Okay. He says no. Any more answers? So is that the always case that binary search can be applied only to the elements which are sorted? Right. The array should be sorted, and only we can apply binary search. Okay, the answer is no, because let me show you this example, maybe that will give you some idea. Okay, so now if you can observe this problem, sir, what is three-pointer approach? So the three-pointer approach is something different. I have also heard of it. Okay, yes, there is a three-pointer approach. Yes, we will try to cover that thing also, but right now we don't need that three-pointer. Yes, there is Digvijay. Yes, there is always another point. Okay, cool guys. So we will cover that maybe in the next sessions, but right now we are trying to build something substantial here. So you see how we reduced and how the problem changed, and then how we reduced more, how the time complexity got reduced as we moved along. Okay, so that's the objective here. The questions are enormous, and there are enormous algorithms as well. Maybe we will start for beginners. Maybe we can do something in some similar fashion. Maybe in next coming sessions we will cover some advanced or some more algorithms which are most important. This is the most important algorithm, binary search, in case when we talk about something related to competitive programming. Okay, this is the most important algorithm. Okay, you can apply binary search anywhere. It will return meaningful results only in the sorted array. No, that's not the case, Manish. That's not the case. If you are able to, let me show you this example, maybe then you can do something by some sorting method. No, sorting will take extra memory, na? Rahul, Rishu. Sorting will take extra memory, right? If you try to sort this thing, this has been already sorted. I am talking about the sorted part, right? So now let's forget something. Let's forget about anything else. Let's try to focus on this binary search approach. Okay. Now the elements are sorted. We know that. Okay. Teach little advanced. Yes, we are going to that. This is just for the starting, that I know how much you guys already know, so that we can just move along. So maybe in the second session we will get some very simple coding you are teaching. Yes, I know this is very simple, but this is not simple if you think about it in a broader manner. Tech or TV or football, whatever the name is, right? So this is, you already know this question, right? That's why you're thinking that okay, this is the approach for someone who hasn't heard about this, right? So how you can reduce, you can apply it on any algorithm, right? Maybe sub-array problem, right? You can do that thing. Okay. Yeah. We will cover many advanced topics. You just have to, for right now, I want you to focus on this part, right? How you reduce the data, how you reduce this time complexity. Okay. Now let's talk about. Now let's talk about this binary search algorithm. Okay. So if you see, the element which is present at the index 0, right, and the element which is present at index 1. If everything would have been simple, right, if everything would have been sorted and there is no error in it, so that then at that time the first occurrence will always be at 0th index, that is even indexes, right? If you can visualize it, I want you to write this thing. So the first write an array, right? I want each and every one of you to take out your paper or pen and just write all these elements: 1 1, 3 3, 5 and 6 6. Now put an index of below that: 0 1 2 3 4 5 6. So if you can observe that every element which is at odd indexes, right, even indexes, will be the first occurrence, right? If the array would have been this, right, let me show you guys. Yeah, so you see, now this 3 is not present, everything is right? So this will be at 0th index, this will be at 1, this will be 2, this will be 3, okay, this will be 4, and this will be 5. Okay, now you see every first occurrence of these elements are at even indexes, right? 0th index, this is at the 0th index, right? 1 is at the 0th index, is the first occurrence. 2 is at the 2 is another index, right? 2 the number 2 is at index 2, which is an even index, right? 4 is at index 4. Maybe I have just confused you guys, so let's put it 3 3 here. Okay, so now this 3 is present at 4th index. So if you can observe, if everything would have been right, so the first occurrences will always would have been at even indexes, right? You got that, right? Now, and the second occurrences will always would have been on what? Odd indexes 1 3 5, right? If everything would have been right. But after that element came which has only one occurrence, after that what would have been done? What would be the case? Okay, now let's see. Now this 4 came, which is only once, okay, then 6 6, then 7 and 7. Okay, just give me a minute, let's remove these things. Okay, now what is the case here? Now this 4th came, right? This 4 number 4 came, which has not been repeated. Okay, after that what happened? 0 1 2 3, this is 0 1 2 3, and this is 4, and this is 5, and this is 6. You see, now let's try to observe this thing. When the number 4 came, all the things got disturbed, right? Now the even indexes got replaced with the odd indexes, right? What do you mean by that thing? The first occurrence of 6 is at index which is odd, and the first occurrence of 7 is again odd, right? Index is again odd, and for 6 and 7 the second occurrence is changed to even. So this is the thing that I want you guys to observe. So after that it got false, the condition got false. So the objective here is you can always apply binary search when you find something similar to this pattern. Maybe the condition is true up until some point, and after that point it is false. So you can easily apply binary search. It's not the case that every time when an array is sorted you can apply binary search. That's why I told you that this is the most important algorithm in the computer world, okay, or when you talk about competitive programming. Okay, this is the most important. Anytime you see this kind of structure, that after some point all the conditions are true, and after some point all the conditions are false, and it reduces, you are able to reduce your search spaces. Okay, so now we got this question right, and now let's try how we try to implement this thing. Now this is the most complex thing in this whole whole session. I want you guys copy the link, put a point. Okay, now I want you guys to just take a pen and paper or copy, and let's try to debug this, because this is very important and you won't be able to understand if I'm just saying and you're listening. Okay, just write a yes if you have a pen and copy in front of you. Okay, just say yes quickly, and now let's try to debug this. Just write an array. that I have written here 1 1, 2 2, 3 3, 5 and 6. I want you guys to try run this. This is very important algorithm and this will solve many of your problems. Okay, just quickly write a yes that you have your pen and copy ready so that we can follow along. Okay, quickly guys. Okay, yes Vignesh, quickly. We're running. Okay, cool. You have your, okay, great. So now you wrote this array, right? 1 1, 2 2, 3 3, 4 5 and 6 6. Okay, you wrote this array. Now put an index below that 0 1 2 3 4 5 6 7 and 8. There are 9 elements, right? How does a binary search works? It works in a fashion that first we try to find a middle element, right? What we will do? We will do 0 plus 8 divided by 2. I'm not talking about the overflow condition here. Right now, let's skip that part. Okay. Now, right now I'm using simple low plus high divided by 2. Okay. Now, what we did? We did 0 plus 8 divided by 2. What we got? We got 4. So, this index 4 will be your mid, and low will be pointing to 0th index and high will be pointing to 8th index. Right guys? You follow along, right? And high will be pointing to index number 8. Right? So now what I want you to guys to observe, if things would have been right? If things would have been, I mean to say they are perfect, there is no such element, whether this is a binary search, this is a binary search. Yes, this is a binary search. We are applying the binary search algorithm here. It's not exactly the same which we have read, but we are just trying to, I mean to say we are using the same concept, but we are using a different, okay, please sir, what do you want, Rishika? Yes, Rishika. Okay. So this is the same approach. This is the same approach that we are using, but we are just a bit modified. We are modifying that our binary search. Okay. Now we found our middle element. I need a Unity developer. Okay, you will get that thing here also. Okay. Is this using bitwise AND? Yes, Manish. Why we are using bitwise AND? It's not that we are using something here. Something advanced. We are using bitwise AND just to find if it's even or odd, because if you write a number 8, convert it to binary, right? It will be 100. The last bit, what will be? For even numbers, it will always be, the last bit will be always 0, right? And for even numbers, right, the last bit will be always 0, and for the odd numbers, the last bit will be always 1. So you can easily calculate what is this a even number or an odd number. You got that, Manish? Quickly, Manish. Okay. Go into a bit depth for a non-programmer. This is something which is very basic, Usair. So this is something basic in terms that what we are trying to build here. Binary search is easy. There is nothing to binary search. We just divide our search space and that's it. Each time we divide our search space. Okay. Yes, Manish. Yes, that's good. Great. So this is Uzair. Maybe you can just, after the lecture is over, maybe you can maybe something. If you are, please tell me what is the language that you are using, Uzair. Just quickly write the language you are using. Maybe I can suggest you something. Okay. So now, right now, focus on this thing that we are using some binary search. Okay. So now we found the middle element which is at 3. Cool, guys. Now, if everything would have been right, then, and we found out the index, right? We need to visualize this thing. Very important. It's and listen to me very carefully, and this is very important. Okay. If everything would have been right, and we found out that this element, the middle element, that is 3, it is odd, right? The last bit is odd, right? The last bit is 1. So this is the odd element. So the last bit is odd. Now what we will do? The last bit is odd. That means this is the second occurrence, right? Yes, Manish. Yes, Manish. This is the easy way. Modulus way is quite outdated. Yeah, you can use the modulus operator, modulus by 2. Yeah, you can use that as well. Yeah. Under the hood, yeah, same thing is happening. Yes. So now we found out that this 3 is at index what? This 3 is the element that is odd, right? So this is the first occurrence, right? This is the first occurrence, right? The index is 4. That means the index is even, right? For 4, what will be the binary? 100. So the index 4 is what? Index 4 is 1, right? The index 4 is having so this is even element, right? The even index. So if everything goes right, so we will visualize that if everything is right, then the element which is mid plus 1 will be the second occurrence, right? Right, guys? This will be the second occurrence, right? So if we are able to find that second occurrence, then we can easily skip these elements. What? 1 1 2 2 3 3, right? Right, guys? You are able to follow along, right? So the index is 4, which is even index, right? So the odd, this will be the first occurrence. So we need to visualize that the second occurrence will be on the fifth index, right? So we will check mid plus 1 element, and if that is true, then we can easily skip this portion. What? 1 1 2 2 3 3. The examples that I have shown on your screen, 1 1 2 2 and 3 3 will be skipped. Now we will focus on this part, 5 5 6 6. Okay. Similarly, once we will now let's go back to the algorithm. Okay. So this mid plus 1, right? We check that mid the last element is 0, right? The last index is 0. So if mid and 1, basically we are just using modulus operator, modulus by 2. We are checking this and is checking only if you are using an even, if this index is even or not. That's it. Then we check if mid plus 1 is the correct element, right? Then what we did, we incremented mid by 2. Why 2? Because mid will be at 4th index. So 5th index has been already checked, right? And then we quickly just shift our this low point or the low index which was earlier at the 0th index. We will shift that to what? 6, right? Right? Okay. Now low will be at 6th index. Now else if these three else ifs won't be executed, we will go back and calculate what? Again we will calculate the mid. So 6 plus 8, that are the indexes. I need you guys to dry run this. I told you earlier that please use it on a pen or paper. Try to dry run it. Okay. Now 6 plus 8 will be divided by 2. Okay. Now what will be the output? The output will be 7, because it will be 14 divided by 2 will be 7. Okay. So the 7th will be the mid element, right, guys? So this will be our midpoint. Now what we will check? We found that this 7th index what we got is an odd number, right? So the first two else is if and else if, the first two statements won't be executed. Now we got on the third, that is if the element if the index is at 1, right? The mid and 1, that is the element is an odd number. Then what we will check? Obviously this is odd, then this is good. If everything would have been right, then the element, this is the second occurrence, right? We already found that the second index will be always on the odd positions, but if the error is there, then we can easily deduce that something is wrong. So we will check mid minus 1. We found that on mid minus 1 there is 5, which is not equal to 6. Okay. Now what we will do, we will quickly, if this will come up in your mind that the error has been already occurred, so we will skip this part as well. What? 6 6. Now then we implement our mid. So the mid will be now the mid will be decremented. So the mid will go on the high, right? So the low is pointing to 6 and high is pointing to 6, right? And both of them are at 5. Okay, you see how we did it? Okay, guys. Sir, please explain if loop condition once again. If loop condition. Okay, so you see, Jyotsna. So basically, what we are trying to do here, we are trying to do something that somehow we are able to skip some elements. So if you see, I want you to write Jyotsna, this example 1 1 2 2 3 3 and 5. Which programming language is this? This is Java. Obviously, we are using system.println, right? So now I want you to write this thing, Jyotsna, on a piece of paper and try to deduce this thing. So maybe after the session is over, maybe you can just dry run it maybe some 2-3 times. You will get this point. This is very easy. Try to implement this example 1 1 2 2 3 3 and 5 and 6 6. Okay, once you will have low at 1 and high at 6. Okay, then mid will be at 3. If the index is even, right, if the index is even, then we will be able to find out that this is something which is having this is the first occurrence, and this is the first occurrence, then mid plus 1 will be the second occurrence if everything is right. Now if something is wrong, then there is a reverse, then these things will reverse. Okay, so then there will be even positions will be at even positions will be the second occurrence, and then will be the first occurrence will be the odd positions. You try to dry run this. I know this is a little bit complicated, but once you will dry run this few times, you will get the hold over it. Okay guys, so now let's quickly move ahead and check one more algorithm, that is sliding window. You need to focus on the algorithms part right now. Okay, the sliding window works in such a fashion that every time we will try to slide our window. Okay, so this is the example, right? 2 1 5 3. Now you need to find out all the elements, right? Sum of the array, sub array. When we talk about sub array, okay, we try to dry run this example, the binary search algorithm. Okay, now let's go back to this thing, right? The sliding window. Okay, quickly, so that we can finish this session on a high note, that we will cover this thing. Okay, now this maximum sum sub array of size k. What do you mean by this thing? You need to find such an array. Okay, such an sub array. Sub array means that all the elements will be contiguous. I mean to say, if you are picking 0th index element, then one index should be also there, 2 should be there. That won't be the case. You will be picking 2 5 and the 3. No, that won't be in case. Okay, this should be contiguous. Okay, so 5 1 3, it's a continuous sub array. Okay, so this is what you mean by sub array. Now we will need to find that array which is having maximum sum of size k. K is completely I mean to say, it is arbitrary value. It can be 4, it can be 5. Okay, now right now I'm talking about 3. Okay, now maximum this sliding window, how does it work? Let me show you an example. Okay, yeah, this is the example 1 2 3 4 and 5. It can be sorted or maybe it cannot be sorted. That's not the point here. Okay, now if somehow I found the sum of these three elements. Okay, yes, that can be applied also. Now right now we are talking about sliding window. Maybe in the next section we will cover Cadence algorithm as well. We will cover very interesting things and the things that are used continuously in competitive coding exams. Okay, now the window size is here, k is equal to 3. Okay, now what I will do, I will just find the sum of these elements. Okay, I found this is 6. Okay, now I will slide my window. Okay, what do you mean by that thing? I will calculate this thing. How I will calculate this thing? I will insert one more element from the front side and remove the index which was already inserted. Okay, I will remove that part. You see, then I will check if it is greater than 6 or not. Yes, it is greater than 6, right? The sum is here 2, 3 and 4. What is the sum? 9. So it is greater than. I will keep track of that as well. So now I will slide my window again to this thing 3, 4 and 8. I will remove 2. 1 was already removed. I will remove now 2 as well, and now I will try to calculate the sum. Okay, you see how the window is sliding. So earlier it was 0, 1, 2 indexes. Then it were indexes 1, 2 and 3. Then there were indexes what? 3, 4 and 5. This is the sliding window protocol. Okay, the sliding window. Okay, this is how we do it. Okay, we will keep sliding our window. That's what we did here. Okay, now what we did, you see, this is quite explanatory, self-explanatory. I just wanted you guys to know that this algorithm can be applied when you're trying to find the sub-array problems. Okay, whenever you find these problems, what? If you're dealing with binary, if you're dealing with something which is sorted, use two algorithms. What? Two-pointer and the binary search. When you're dealing with sub-array problems, always think of this sliding window, or what Big Fan said, use Cadence algorithm, or Manish. Yes, that we cover later. But if right now we can just think of what? Whenever we are dealing with sub-array problems, always think of what? Sliding window. right? At least for now, okay? So now what we did, we just kept sliding our windows. If you can see this algorithm, this is quite self-explanatory. What we did, we calculated the sum of the first three elements, okay? Right now you can also pre-compute it. What pre-computation? What you will do, you will just pick three elements or the k elements and put them in an array. Okay, put them in some element or some variable. Okay, you got the 6, right? The 6 has been already done. Then you will loop around one element and keep removing the previous element, keeping a track. You just dry run this example, everything will be clear. Now I don't want you guys to I don't want to continue further. There are some more questions that I wanted to cover. Okay, so due to some kind of time constraint, and I want you guys to implement these things. Now I want you guys to do two things. First, whatever I have taught, revisit the session and implement these things. Okay, implement these things and keep a track of what are the problems that you faced in an Excel sheet. Maybe some Excel sheet, create some Excel sheet. Okay, and put the problem name and the time you exhausted for solving that problem. Okay, and write the type, or I mean to say, if you used what type of algorithm you used. Did you use two pointer? Did you use sliding window? That way you will keep a track and you will have a vision that these are the things you covered. Try to solve 2 or 3 problems, maybe 5 problems a day. You will get just a good hand over these competitive coding problems. Another thing, right now there is going a session. Yes, I will try to cover that thing as well. Yeah, big fan. So also right now there is going a competition on the Hacker Earth. Yeah, the Auto Rabbit thing. If someone of you is of 2020 pass out, okay, he or she can apply. Okay, when is the next session? That will be informed to you guys. Don't worry. Right now it is having a deadline of maybe 12 today. Okay, so go to that session. I know you are just a beginners. Okay, some of you are pro as well. I mean to say, no one can be a pro on such a thing. Okay, you have to keep updating yourself, keep upskilling yourself. Okay, you need to do a lot of hard work in this. So right now there's this competition going on. I want you guys to go and participate in that. Auto Rabbit is the name of the competition, and it will be up to 12 p.m. Today. This is the deadline. Yeah, we will have a next session. Yeah, for sure. Okay, it's having Java as its language. You can only use Java for your coding skills. Okay, for your coding problems. Okay, it's for 2020 pass outs on Hacker Earth. Okay, go and register yourself. I don't know if you can register. It's having a deadline of today. Okay, on Hacker Earth. Okay, and next thing, what I want you guys to do, implement each and everything that I taught you today. Implement it. Keep a track of Excel sheet. Keep a track of that algorithm cheat sheet which I showed you on the GitHub. Keep a track of that as well. Okay, thank you so much, guys. Thank you so much. Implement these things. Yeah, thanks, Jyotsna. I don't know about the certificate thing. Maybe not. We cannot use C++. Yes, you can use. No. In that competition, no. You cannot use. There's a constraint to it. That Java only, and it's for 2020 pass outs. Okay. Thank you, Pragati. Thank you, everyone. Thank you, everyone. Thank you so much, guys. Thank you, Flaky Flicks. Thank you so much. Thank you.